I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This video is over inductive reasoning, which is in the book, chapter 2, section 1. Here are 3 vocabulary words that you need to know. A conjecture is an unproven statement that is based on observations. Inductive reasoning is also based on observations. It's the process that includes looking for patterns and making conjectures. I want you to notice the similarities between conjecture and inductive reasoning, and that is observation. And a conjecture is unproven. So it's just something that we're observing. So for example, if you get a failing grade on a test, one observation I or you might have is that you didn't study well enough. That's an observation. There's no way to prove that. That may not even be true, but it's just an observation that can be made. A counterexample is a specific case that shows that a conjecture is false. So once you make this statement based on observation, then you may be able to prove that it's actually not true by giving a counterexample, which I'll show you later. So we're going to identify patterns in order to make conjectures. So here I have 2 sequences. So looking at sequence A, the pattern is -2, 1, 5, 10, and 16. So we want to see if we can make a conjecture about the next 3 terms and then possibly even about any term after that. So I'm seeing a pattern. I'm seeing that this is +3, this is +4, +5, +6. So my conjecture is that the next term is going to be 16 plus 7, which is 23, that the next term will be 23 plus 8, which is 31, and that the next term would be 31 plus 9, which is 40. Example B, I have the sequence 1, 2, and 4. I could make the conjecture that this is +1 and this is +2, so then I would have +3, which is 7, +4, which is 11. I could also make the conjecture that this is ×2 every time, which would make this 8, 16, 32. So there's sort of 2 different conjectures I could make there, and with more information, I could maybe decide which one would be best and or which one is the right one depending on the context. So here we're being asked to make a conjecture about the sum of any 3 consecutive integers. Consecutive means one after the other. Integers are the positive and negative whole numbers. So let's just try some examples. Again, I need to make a conjecture, so I need some observations. So if I add 3 plus 4 plus 5, 3 plus 4 is 7, 7 plus 5 is 12. If so just from that, I can't really make an observation. Well, I mean, I could say, well, 3 times 4, if you multiply the first 2 numbers, you get the answer. But that's only one observation. I need to have more to be able to justify. So 7 plus 8 plus 9. So 7 plus 8 is 15, and 15 plus 9 is 24. So does that work? 7 plus 8, 24? Or 7 times 8? No, it's not 24. So that doesn't work. So let me try another one. Let's go with 5, 6, and 7. 5 plus 6 is 11, plus 7 is 18. So now I have 3 examples here. Let's see if I can come up with a conjecture about, again, I'm trying to figure out what this number, where that number might come from, or what's an easier way to find that number. So if you think you can, pause the video and maybe try to figure out the conclusion here. All right, so what I'm looking at is, I'm noticing that all 3 of these are multiples of 3. And if I notice that if I multiply this 4 times 3, I get 12. If I multiply 8 times 3, I get 24. And 6 times 3, I get 18. So I wonder if the sum is going to be equal to the middle number times 3. So let's try another example. So let's do 19, 20, and 21. So if I use my conjecture I just came up with, which is the middle number times 3, then this should be 60. because 20 times 3 is 60. So let's see, 19 plus 20 plus 21, 9 plus 1 is 10, 2, 4, 5, 6. Sure enough, it works out. So that seems like that's a pretty good conjecture. Now let's look at what a counterexample is. So here's a statement. If n is an integer, remember integer is positive and negative whole numbers, then negative n is positive. So when I say counterexample, I mean, so if I want to figure out if this is true or false, if I can come up with one example where it doesn't ring true, then that's called a counterexample, and then I could say that this is false. So if n is an integer, so if n is 8, then negative 8 would be negative n, but that's not positive, that's negative. So already right there, we have a counterexample, which makes this statement false because of the counterexample here. Now, is this true for some integers? Yes. If my integer is negative 4, then negative 4 is positive 4. So it works for some, but again, because of this one example where it doesn't work, then it's a false statement. Looking at example B, given that n is an integer, 2n minus 1 is always odd. So if n is 5, 2 times 5 minus 1 is 9. That's odd. What about if I plug in a negative number? 2 times negative 7 minus 1. 2 times negative 7 is negative 14 minus 1 is negative 15. That's also odd. So you could keep trying to plug in numbers maybe that you think might make it false, but I don't think you're going to find one that's false here. So there's actually not a counterexample. There is no counterexample. This is a true statement. If you think about it, the reason it's a true statement is because if you multiply 2 times any number, you're going to get an even number. And then if you subtract 1 from that, then you'll always end up with an odd number.
I've been waiting way too long.